Dear learners, this is a session we will speak about the design of cylinder. Cylinder is a part in an internal combustion engine where combustion is taking place. There are some design parameters which to be maintained for the proper working of an engine. So today we see what is happening in a cylinder and how the design parameters are designed according to the given loading conditions. So this is a schematic representation of a cylinder. In this cylinder, this is a cylinder block, and inside the cylinder block, there are liners given. These liners are given in the cylinder block to meet out the worn out in the cylinder. So there may be two kinds of liners. One is called as dry liner and another one is called as wet liner. If the water space is not in contact with the liner, then it is called as dry liner. If the water space is in contact with the liner, then it is called as wet liner. Today we have taken a cylinder that is having a wet liner, and there is a cylinder head which covers the block. So this water space is given for cooling purpose because enormous amount of heat is produced while combustion is taking place. And this cylinder is subjected to longitudinal stress as well as the circumferential stress. So the design should meet out this longitudinal stress and circumferential stress what is generated inside the cylinder. So this is the apparent circumferential stress that sigma c is equal to P max into D by 2T, and this P is called as the gas pressure inside the cylinder, and apparent longitudinal stress is sigma L is equal to P max into D square by do square minus D square, and this D is the core diameter of the cylinder, and this is the inside diameter of the liner, and this DO is the outside diameter of the cylinder wall, and it is the outside diameter of the cylinder liner, and this T is the thickness of the cylinder wall, and cylinder head thickness is represented as TH, and there are requirement of studs to keep the cylinder head in contact with the cylinder block, and there is a space for water, and there is a water jacket thickness from the cylinder liner to the water space, and these are the parameters that governs the cylinder that will be suitable for the required desired combustion. And this bore diameter, it can be calculated by using this indicated mean effective pressure and the brake power and the mechanical efficiency, and this is the formula where the indicated pressure is equal to Pm. This is indicated power, that is equal to Pm. Pm is referred as the indicated mean pressure inside the cylinder, and L is the length of stroke. L is the length of stroke, and A is the area of the bore, area of the cylinder, and N is the number of working strokes. It is mentioned here, and Pm and L is the stroke length, N is the number of working strokes, and that is N will be taken as capital N for two-stroke engines, and the small n will be taken as capital N by 2 for four-stroke engine. If it is a four-stroke engine, then it may be capital N by 2. If it is a two-stroke engine, that it may be small capital N for capital N, and N is the engine speed in RPM, and A is equal to pi by 4 D square. If you substitute, and this is called eta is called the mechanical efficiency. Mechanical efficiency is equal to brake power by indicated power. Whether indicator power is calculated using this formula, and that has been substituted in this formula, then you will find the bore diameter. You will substitute pi by 4 d square instead of a, and L is equal to a length. This is length of the stroke. That would be equal to 2 d to 2d, and capital D is called as the diameter of the bore. Using this, you can find out the D, and we can calculate the length of the cylinder. Only from this formula we can get the length of the stroke, and using this formula we can find out the L is equal to 1.15 into L, length of the stroke. Then using this formula we can find out the length of the cylinder, because apart from the stroke length, you will be having we will be having clearance inside the cylinder. That could be calculated using this formula. L is equal to 1.15 into L, and the cylinder head thickness could be calculated using this formula, capital D into square root of K into P max by sigma C, and K is taken as 0.162. It is a constant, and sigma C, it has been calculated using this ultimate tensile test by factor of safety. Otherwise, in the design data, it has been given at sigma is equal to 30 megapascal to 50 megapascal. You can take any value in this value and you substitute. This P max is the gas pressure, and this P max is 9 to 10 times of indicated mean effective pressure. You can take P max is equal to 9 into Pm, or otherwise you can take P max is equal to 10 into Pm. And using this formula, thickness of the head could be found out. And for calculating the thickness of the wall, this is the thickness of the cylinder wall, and that will be equal to P max into D divided by 2 into sigma C plus C. And C is the reboring allowance, and it is given as reboring allowance is given. There is one table we can find the reboring allowance in the data book, and this is sigma C, and it could be taken as 35 to 100 megapascal, or otherwise it could be calculated using this UTS by Fs. UTS is the ultimate tensile strength, and Fs is the factor of safety, and you could calculate the thickness of the cylinder. Otherwise, there are some empirical formulas that is taken as T is equal to 0.045 D plus 1.6 into 6 millimeter, and for a water jacket space, it could be taken as 0.032 D plus 1.6 mm, and water space it is taken as 0.08 D plus 6.5 mm. And coming for this studs, stud is an important thing in the cylinder that keeps the cylinder head affixed with the cylinder block. So for number of studs, there is one formula. You can go for this 0.01 D plus 4 mm to 0.02 D plus 4 maximum. This is the minimum number of studs, and this is the maximum number of studs, and the number of studs should lie within these values, and it would be an even number, maybe 2, 4, 6, 8, 10, or 12, and it could be found out using this formula. And if the number of stud has been found out, and we could go for a formula called as dc is equal to d into p max by 2t, where dc is the core diameter or root diameter of the pitch of the stud, and d is the nominal diameter of the stud. That could be calculated using dc by 0.8. And and finally we can find the pitch of the stud, that is calculated using this pi dp by number of studs. This is z, and this pitch, this dp is the pitch circle diameter. That could be calculated d plus 3 into small d, I mean pore diameter plus 3 into nominal diameter of the stud. And for minimum pitch, it could be 19 square root of d minimum and 28.5 into square root of d maximum. If the calculated pitch lies between this minimum value of the pitch and the maximum value of the pitch, then the number of studs calculated in this question is correct. This is all about the design parameters of the cylinder. Using these formulas, the design parameter could be found out very easily. And that's the session about the design of the cylinder. And you could be very well in finding the using the formulas to find out the design parameters. And thanks for watching this video. Thank you.